I don't know what I'm going to have to do. It's just crazy. All right. Well, it's recording now. So what we were talking about before is not relevant unless she contacts me and tells me she has a Mac. All right. So anyway, the textbook for chapter 1 is pretty much definitions, right? If you read, did all of you read it?
Yep.
And did any of you have any questions about chapter 1? I mean, I'm going to go through it. Maybe we'll do some exercises tonight, but it's pretty elementary, I think. Unless you thought it wasn't elementary, so it's either elementary or it's not. So how did you understand the idea of measurement? I mean, the definitions of the measurements. That might have threw you a little. Did you understand that?
Got it.
Yes. Okay.
Yeah, got it.
Rose and Han, you're okay with that? All right. So again, I don't want to go through those PowerPoints because again, I don't think they're very good. At least the one for this chapter. Do you all have the textbook in front of you or near you? And yes?
Yep.
You all have it? At your desk? Okay. So maybe what I'll do is we'll go through some of these exercises tonight. Since you've all read the book and it's not really something I need to really explain, maybe we should just go through the exercises and just to confirm that you feel comfortable with all the concepts. And let's see, on page, I think the ebook hopefully has the same page numbers as the book I have here. You guys understand the difference between descriptive and inferential statistics, that definition, the difference? Some students do get confused sometimes with that. Because descriptive just means it's like looking at some results. You know, you calculate the mean, or you create a dot plot, and that's it. That's called descriptive statistics. And there's no interpretation at that point. Okay, you're not trying to interpret it for the whole population. You're just saying you create it, you're looking at it and saying this is what I see, and that's it. Inferential statistics means that you are commenting, you're interpreting what you're looking at. All right, you're making a judgment. Now, inferential statistics has actual procedures that you go through, which we'll learn as we continue throughout the course. But in general, it's really you're trying to make some sort of conclusion from what you're looking at. Let's see if they have a good example of this. I think there's something like this in the exercises. Yeah, so exercise 1.3 to 1.5. It's in the textbook. It's page 8. Same page on your ebook. Yes. Okay.
Yes.
All right. So let's look at 1.4. Let me read through it. It says in 2008. Piedmont Natural Gas Corporation sold 50.4 million cubic feet of gas to residential customers, an increase of 3.7% over the previous year. Does this information represent descriptive statistics or inferential statistics, and why? Anyone can answer.
I'm sorry, where are you again in the textbook?
Exercise 1.4 on page 8. Is it on page 8?
Yes, 34 with the ebook navigation, but it's page 8 on the page itself. Yes.
Okay.
Right.
There you go. All right, you see it? Exercise 8. Excuse me, exercise 1. So,
yep.
Good. So is that, yeah, if I try to display it on the screen, this here, it doesn't show very well. I tried it today and I can hardly read it. That's why I got the textbook for me. So let me read it again. In 2008, Piedmont Natural Gas Corporation sold 50.4 million cubic feet of gas to residential customers, an increase of 3.7% over the previous year. Does this information represent descriptive statistics or inferential statistics? Yes, Steve.
Descriptive, because it seems to be the complete amount of cubic feet of gas, and it just makes a flat remark about its relationship to the previous year with no prediction of anything out, anything in the future, or making any other claims that aren't obviously countable in there.
Right. That's exactly right. So it just describes the numbers, right? You're describing what you're looking, what the results. You're not trying, like you said, you're not trying to interpret or predict. You're not creating a model and saying, all right, based on this is what I think is going to happen in the future, right? So this is definitely descriptive. Everybody agree with that? Okay. All right, let's look at 1.5, the next one. An article in a fitness magazine described a study that compared the cardiovascular responses of 20 adult subjects for exercises on a treadmill, on a mini trap trampoline, and jogging in place on a carpeted surface. Researchers found average heart rates were significantly less on the mini trampoline than for the treadmill and stationary jogging. Okay. Does this information represent descriptive statistics or inferential statistics? So read the statement researchers found and see if that sound like a descriptive or was it inferential there?
It sounds descriptive because there isn't another source, or not source, there isn't like a decision being made with the information given.
Okay. All right. So there's definitely something descriptive here, but do you think there's anything inferential at all here? In that last sentence there, researchers found.
Yeah, I figured that's inferential
And Han, why would you think it's inferential?
because I feel like it infers the average heart rate from 20 adults.
Yes. So you're saying that the statement here seems to imply they're stating something that seems to be for the whole population, right? Not just for the sample. So,
Yeah, yeah.
right.
Mm-hmm.
So yeah, it's a little tricky, Mo. And even I, when I read something like this, I thought originally that, yeah, that looks descriptive. But then I read it again, and I think if they said something like, researchers found that the 20 subjects had average heart rates, then that's sort of descriptive. But they didn't say that. They say researchers found average heart rates were significantly less. In other words, that was, when they used the word found, that they concluded. They came to some conclusion. Okay. So it's tricky. That's why I'm going over this, because it's, in this case, I think, even though you're right, it's descriptive, right? But it's also inferential, because they're automatically going to making that step, going from the particular sample to the whole population. They didn't say that, right? They didn't say the average, they found that the average heart rate for the population. But because they said it in this way, you sort of feel like maybe that's what they meant. All right? So
okay,
it's a little tricky. That's why I wanted to bring it to your attention. All right? All right. All right. Now, quantitative versus qualitative variables. Qualitative variables are variables that we don't do math with. That's the way I describe them, all right? I mean, you could say they're labels, right? There could be words. But sometimes qualitative variables could be numbers because, for example, it could be rankings, right? Ranks from 1 to 10. Well, when you rank, maybe you're looking at the top 10 grossing movies of 2019 before the pandemic, right? They were ranked from 1 to 10. Well, you could have easily just switched and actually spelled out the word 1, the word 2, the word 3, and it would mean exactly the same thing. So that's qualitative. You're not planning to do any math with a ranking. The ranking, even though it's numbers, sometimes numbers are just placeholders, right? They're not really, they're not there to actually calculate anything. So the qualitative variables are basically labels, right? And sometimes labels have numbers in them. I mean, phone number. Phone number is not really a quantitative, right? It's not really quantitative. You don't do math with a phone number, but phone numbers are filled with numbers. So that's the way I want you to look at qualitative variables. So they're labels, right? You can replace, if there's numbers there, you can replace them with words. There's two types of qualitative variables. There's the nominal. Nominal means that there's no inherent order to the categories, right? To the categories, no order. For example, if you went to a used car lot, and let's say they sold 4 different types of cars there, used car lot. There was Toyotas, there were Hondas, right? There was Hyundais there, and there was BMW, all right? Yeah, BMWs. Well, there's no particular, you can put those names in any order you wanted to. There's nothing special about the ordering of those names. That's called nominal qualitative data. And the way to look at these ways of these 4 different types of data that we're going to talk about is in terms of how much information do you get. A pure label like Honda has information, but it's not the most informative. Okay, it's not the most informative of the type of data. It's the least informative. It's just simply a label. The second type of qualitative variable is called ordinal. Ordinal. I just have trouble saying that. O-R-D-I-N-A-L. Ordinal. Ordinal data. And there's a natural ordering of these labels. For example, if you let's say you were doing a survey, and one of the questions you asked in the survey is the person's age. Well, one thing that you may want to do with the ages is to create age categories and count the number of people in each of the age categories in that survey. So you might say category number 1 is from age 20 to 29. 29, just under 30. And then second would be 30 to 39, 40 to 49. Those have numbers in them, but they're labels, aren't they? They're labels. But there's a natural ordering. If you're going to display that, you would definitely display 20 to 29 first, 30 to 39 second, and like that. That's called ordinal qualitative data. Now, numeric data could be also ordinal, but in many cases, it's qualitative. The ordinal data means you can order them. Now, quantitative variables, you can do math with them. That's the way I look at it. You can do mathematics with them. There's 2 types in general, 2 types of quantitative variables. There's discrete and continuous. A discrete quantitative variable means that the values of that variable are individual points on a number line. and there's a limited number of them, okay? A finite number of points on a number line. You can distinctly see. You know, the best example, of course, is counting, right? When you do a count, that's discrete. The other type is called continuous. And continuous means that when you measure something, it could be any value. Now, it may be limited by the measuring instrument. For example, if you weighed somebody, right, on a scale, the scale only has there's only so many decimal places, right? Even the finest scale only has maybe 3 or 4 or 5 decimal places. I don't know. But my point is that the limits of the measuring instrument should not make it into a discrete variable. Okay? You can actually, when you weigh somebody or weigh something, it could be any value. And literally, a continuous variable could be any value in between 2 points. In other words, it's an interval. So later on, when we talk about probability, and we talk about what are called discrete probabilities versus continuous probabilities, discrete probabilities means we have a limited number of values to look at. And continuous probabilities means we have unlimited. Because you remember from mathematics, you have an interval, there's an infinite number of points. And it doesn't matter how narrow that interval is. It's kind of interesting, isn't it? That no matter how wide or narrow the interval has infinite number of points in between any 2 points. And that's the definition of a continuous variable. All right. Nominal quantitative variables can also be defined in terms of measurement, the types of measurement. And there's 2 types of measurement for quantitative variables. The interval scale and the ratio scale. It's a little tricky, actually. Now, you might read through this and think, oh yeah, this is fine, I understand. Let me give you an example of why it's tricky. Let's say we were measuring something we're measuring the temperature, maybe your temperature. Maybe you think you may have, God forbid, COVID, right? And so you're taking your temperature. I've done this before, right? I get a couple chills and I think, all right, better take my temperature. So I take my temperature, right? I take my temperature, and then I take it again and see it's different. The question is, when you take temperature, let's forget about the human body. Let's say you're taking the temperature of outside. And let's say one day during the summer, it's 80 degrees. And then say later on when it gets cold, it's 40 degrees outside. Is it true that the 80-degree temperature has twice as much heat as the 40-degree temperature? I don't know if you've ever thought about that. Steve is saying no, and Hannah's saying no. How about you guys, Rose and Mo?
No.
No. It doesn't, does it? Although I've had people have to think about it because they've never thought about it before, right? And they're thinking, well, wait a minute, does it really mean that? The answer is really no, right? Because, and the other thing about the temperature scale is that 0 degrees. Does that mean lack of heat or no heat? It doesn't. So the interval scale has those 2 qualities. You can do math with them, obviously, right? You can subtract, for example, 2 temperatures. You can say one temperature is 5 degrees higher than another temperature. You can certainly say that. But one thing you cannot do with any that's meaningful is take ratios of temperatures. They don't mean anything. And the other thing is that the 0 doesn't mean anything in general, because, you know, if you said 0 degrees Fahrenheit, does it mean no heat? Well, doesn't that also Can't you convert that to centigrade and it's no longer 0? Right? There's the sort of thing right there. So interval scales are like that. You can do some math with them, but you can't take ratios, and the 0 is not meaningful. It doesn't mean having nothing of that quality. It doesn't mean no temperature. Look at ratio scale. Think about home runs in baseball. Home runs in baseball. Well, let's say we list the number of home runs by a team in any particular year, all right? And we have a rank, but forget about the ranking part. Just think about in your mind all the home runs a team hits in a particular year, right? Some teams don't hit very much, right? They might hit less than 100 or even 50 maybe home runs in a year. And then you have, teams that really bash the ball, hit over 200 in a year. I don't know if you're a baseball fan. Maybe not. Is the number of home runs in a year, is that interval? Is it ratio? Is it ratio? Yes. Ratio means you can take ratios and it's meaningful, and it's also 0 means meaningful. So 0 home runs means lack of home runs, right? It actually means no home runs. And if one team hits 200 home runs and the other team hits 100 home runs, the team with 200 home runs does hit twice as many home runs as the team that hits 100 home runs. And that's a ratio. Now let me ask you something. Is a number that's ratio, is it also interval?
Yes.
Yeah, it basically anything that's on the ratio scale is also interval. It's actually also ordinal. Right? The ordinal can also. You can't really say it's nominal, but I guess you could write the words out, right, and make it into a label if you wanted to. So this is why I'm saying that when you go from nominal to ordinal to interval to ratio, you actually have more and more information. More and more information. This is why in statistics, it's better to have more information than less information. Some people say, well, what if I have something in the ratio scale? Would it be okay to create categories out of that? Like age, right? Age. Age is ratio, isn't it? Because somebody's 50 is twice as old as somebody 25, and somebody who's 0 was just born, right? They have lack of age. If you make that into a ordinal scale, right? By creating age categories, is that okay to do? Yeah, well, it's okay, but then you lose information. Because now you have 2 endpoints and you're throwing in, right, people into that category and you're not knowing anymore how old they are. So you'll lose information as you go down. As you go from ratio down to nominal, you lose information. So it's always better if you can, if numeric especially, is to stay with the highest scale possible. The temperature, the highest you can get is interval. For number of baseballs that hit out of the park, that's ratio. Now, let me ask you a question. The number of baseballs that a baseball team hits in a year, we know it's ratio. Is it discrete or is it continuous? I didn't mean to stump you.
I would
The
guess
number of
discrete.
baseballs hit in a year would you consider it to be Discrete or continuous? Think about a number line. Continuous random variable is a continuous variable is any value in between two endpoints. Is the number of baseballs that you hit. Is that continuous or discrete? What would you think?
I would say discrete.
Discrete. Yeah, I don't think anybody's going to hit an infinite number. You're not going to have an infinite number, but they're points on the number line. They're whole numbers, right? So you can picture them. You can picture doing a dot plot with one of them. We're going to get to dot plots next week. Dot plots indicate discrete values, all right? You don't create dot plots for a continuous variable. You would only do that for a discrete variable. Okay. All right, so let's look at exercise 1.8. All right. In the textbook, it's page 10. I don't know what it is for the electronic book. But we'll just flip over till you get to 1.8, where it says the Acme School of Locksmithing. You see that one? All right, the Acme School of Locksmithing has been accredited for the past 15 years. Discuss how this information might be interpreted as a qualitative variable or a quantitative variable. Now, this is a sentence with pieces of information, right? Probably your initial impression is when your initial focus was on the 15 years. But there's other pieces of information in this. There's the Acme School of Locksmithing. That's what kind of is that qualitative or quantitative?
Qualitative.
Qualitative. Is it nominal or is it ordinal? Anybody besides Steve?
Nominal.
Nominal, right? Because Acme, unless you're doing something in alphabetical order, which is really not any good reason, it's nominal, right? Accredited, I guess. All right, forget about accredited. 15 years. Is that qualitative or quantitative? No. I only have 5. I had 4 of you. I'm looking at 4 of you, including myself. I'm in the middle, so I'm going to call on you. I can easily do that. I'm looking at you. So Mo,
That'd be
15 years. Is that quantitative or qualitative?
qualitative.
What is it?
Qualitative.
Qualitative? 15 years? 15? The number 15.
I know it's a number, so it's quantitative, but isn't it descriptive and not really, there isn't any math involved in that as far as what we can do for statistics? It's just a descriptor?
That's a good point. It could be considered to be nominal. It could be. Remember what I said before, each of the higher level scales, the ones that have more information in them, can be considered to be lower scales also. So let me rephrase the question. Is 15, what is the highest possible scale that it could be? You're absolutely correct. It could be nominal, but it's something more. It could be more than that, right? Could it be ordinal too?
Yeah.
That's true. Could it be interval?
Well, I don't know what you would compare it to as far as a ratio goes.
All right, is it ratio?
Yeah.
Ratio means you can take ratios. I mean, 15 years divided by 5 is 3 years, right? 3, right?
Mm-hmm.
So 15 years is definitely 3 times more than 5 years. And
Okay.
0 years is meaningful too. So this is a ratio, right? 15. Remember, years in this case here is units of measurement.
Okay.
So we don't consider that to be a scale, all right? It's a description of the type of measurement. But in terms of the level of measurement, the 15 is definitely the highest level is ratio. So this is ratio quantitative. You can say it that way, right? Ratio has to be quantitative anyway. All right, let's look at 1.9. 1.9. Jeff Bolin, a labor relations expert, has collected information on strikes in various industries. Jeff says Industry A has been harder hit by strikes than Industry B. In what scale of measurement is this information? More, I think they want you to focus on the strikes, right? It says Industry A has been hit harder by strikes. I guess more strikes, let's say, right? Does that mean more strikes? So let's look at the, think about in terms of the number of strikes. Is that quantitative or qualitative? The number of strikes. Let's just focus on that part of the statement. There's no numbers there, right? No information. You can't do math. However, so therefore it's not quantitative, qualitative, right? But is it nominal or ordinal?
Ordinal.
Ordinal. And why would you say ordinal?
Because you can rank them, but you don't know what the distance between them is.
Right. So you can see here, this is a good example, right, of ordinal. Ordinal doesn't have as much information as interval or ratio. We don't have the numbers. We certainly rank them, right? In terms, Industry A has more, right? So we will rank Industry A first, let's say, and Industry B second, if we're only comparing those two. It's ordinal. You could say it's nominal too, but the highest level is ordinal. It's not interval. There's no numbers. There's no calculations to be done. Let's look at B. Industry C has lost 10.8 days per worker, while Industry D has lost 14.5 days per worker. And what scale of measurement is this information? So they're saying, what's the highest scale in this case here? Highest scale.
Ratio.
Ratio. Ratio. Because you can take ratios here, right? And it's meaningful, right? The number of days per worker, if you divided 14.5 by 10.8, that's meaningful. I'll go through what's the factor? How much more has Industry D had in terms of lost days than Industry C? And zero means something too, right? Industry that has 0 days lost per worker, that's good, right? That's a good thing. And it's meaningful, means something. So yeah, ratio would be this case. But you could picture saying interval, you could picture saying ordinal, right? You can rank them. Industry D had lost more than Industry C. And certainly you can write this out and say it's nominal too, but the highest level is ratio. All right, let's look at 1.10. The Snowbird Ski Lodge attracts skiers from several New England states. Each of the following scales of measurement provide one example of information that might be relevant to the lodge's business. I don't know if you want to do this one. You could try. Can you think of something? Picture you're running a ski lodge and some information about your business that would be strictly nominal. What would be an example of that?
People from different states.
Sure, the state, right? Whatever state they're coming from. Great. How about B, ordinal?
Hmm. I guess you could maybe, I don't know how useful this would be, but the daily average temperature, something like that.
Okay, sure. That's true. You could do that if you want. That would be more interval, right? But I would answer interval for that one. But how about ordinal? Well, let's
Oh,
say it's the highest level one is ordinal. Can you think of something that would be ordinal?
The distance each visitor traveled to get to the ski lodge, because it's different New England states, so it'd be different distance for every person.
Sure. Although the highest level there would be numeric. So, but that's a good example. I like it. Can you think of something that would just be strictly ordinal without the numbers? Anybody would come up with something without numbers? It's kind of hard to do, isn't it? It's not the easiest thing to do. It's easier for them to do something numeric. Sure. I like the idea with the states. That was a very good choice for nominal. Ordinal.
If you look at page 10 for the examples for ordinal scale,
Yeah.
it has names. It kind of rank these different peoples. Can we rank different states for the peoples, for the numbers of people coming from the states?
Mm-hmm. Okay. If you rank them based off of what, maybe population size or something, rank.
Right. Yeah.
You could do that. Sure. Okay. How about ratio? How about interval? I think we already did interval. We did temperature, right? Temperature is the easiest one. Can you think of something else that also could be interval besides temperature?
Hmm.
Not easy to do, right? Interval's kind of tough.
You could say skill level of the skiers who come.
Skill level. So there's some sort of numeric value for the skill
Well, actually,
level.
that's more ordinate than interval, I think. Actually,
Hmm. That's a good example for ordinal, sure. I like that example actually for ordinal. Interval. Can you think of something? How about, I'll give you an example. How about time of day that they check in?
yeah, that's good. Yeah, that would work.
Yeah, it's numeric, but it's not ratio. And how about ratio? Ratio should be the easiest one.
Yeah.
Give me an example of that. How about rows? Rows, give me an example. You've been quiet. How about the example of ratio one for 1.10? The lodge.
Each state, like doing the states.
What's that?
The state.
Well, it's numeric. It has to be numeric. Ratio is
Can you
numeric.
hear me?
And remember, it has to be something that you could take ratios of. And also the zero is meaningful when you say zero of it. So what's the obvious one? The one that's the most obvious?
How many attracted skiers?
What is it?
How many skiers attracted in the states?
How many skiers? Okay, that's a good one. You could say number of skiers in the states that you came from. one I was thinking of was just how much you paid for the room. Money is an obvious ratio, isn't it? Yeah. You can always go back to money. Zero money means you're broke. All right, good. And so I think that, oh, well, there's a couple more here today. If there's anything else here in this chapter. There's some exercises at the end of the chapter. Let me see if I can find one that's good. All right, 1.15, this is a little further on in chapter exercises. It's right at the end of the chapter. As a research firm observes that men are twice as likely as women to watch the Super Bowl on television. Does this information represent descriptive statistics or inferential statistics?
Inferential.
Inferential, right? Did everybody agree with that? Yeah, because they're coming to a conclusion here. They're not even giving you any numbers or a graph or anything. This is definitely inferential. Do you think most people in general, when they mention something, do you think they're doing inferential? If you ask somebody a question about, do you think?
Yeah.
Yeah, it is. It's true, isn't it? Most people don't do descriptive. It's hard. You have to do some work to do descriptive. Inferential is easy to do. Anybody, I mean, go onto Facebook or any social media any day, and you'll find people inferring things like crazy. Doesn't mean it's true. Doesn't mean there's any facts that are behind it, but it's definitely inferential. Inferential is easy to do, but it's hard to actually do it correctly. And that what we're going to learn later on in the course is the correct way. Statistical inference at least. All right. 1.16, for each of the following, indicate whether the appropriate variable would be qualitative or quantitative. If you identify the variable as quantitative, indicate whether it would be discrete or continuous. This is a nice little question, and at Rowan University, in some of the courses I teach here, that's a final exam question, right there. Believe it or not. All right, look at A. Whether you own a Panasonic television set. This is really old. I don't even think they have Panasonic. Do they have Panasonic anymore? I don't even know if they exist anymore. All right, A is whether you own a Panasonic television set. Is that qualitative or quantitative?
Qualitative.
What is
Yeah.
it? Qualitative? Is that what you said? Yeah. Because the answer is yes or no, right? That's definitely. Now, here's the deal. If you were a researcher and you were creating a code book for your variables, right? Most likely what you would do in this case here is assign the number 1 for having the Panasonic and assign the number 0 for not having it. Binary choice. That is definitely qualitative, even though you're using numbers, all right? So we might code it as a number into our computer software program like Minitab. It's definitely qualitative. B, your status is either a full-time or a part-time student.
Quantitative?
Did I hear qualitative or quantitative?
Quantitative, because it's counting the amount of time that you spend studying.
Ooh, that's interesting. I like your reasoning there. Mo, you have very subtle reasoning. That's really good. I like that reasoning. I don't think that's what they're asking for, but it's really good
wrong, though.
reasoning.
The vibe that I'm getting.
Huh?
It's
What's
wrong,
that?
but it's kind of the vibe that I'm getting.
I like that. I like what you said there, though. It never crossed my mind to think of it that way, but you're absolutely right. But in this case here, if you were going to code it into the computer, you would probably have two choices, full-time, part-time, right? And you would code one of them with a number, the other one with a number, but it would be considered to be qualitative because it's basically one or the other. It's a choice. It's a
Okay.
label. It's a label. But that's really interesting that you mentioned it that way. I'm serious. You caught me by surprise. And it's very good reasoning. So if you said that on the test and it was free form, I give you credit for that. That was really good. All right. C, the number of people who attended your school's graduation last year. Now remember, if your answer is quantitative, you have to tell me whether it's discrete or continuous. So the number of people who attended your school's graduation last year, is that quantitative or qualitative? Yes. No, Steve.
Qualitative or quantitative, excuse me.
Quantitative. And is it discrete or continuous?
Discrete.
Discrete. So you can always recognize discrete by when they say the number or counting or something. That's the individual points on the number line, usually whole numbers, right? It doesn't have to be whole numbers, but in this case, it is. D, the price of your most recent haircut. This is an interesting one. The price of your most recent haircut, is that qualitative or quantitative? And if it's quantitative, is it discrete or continuous?
Well, it's definitely quantitative.
Yeah, definitely quantitative. But you're not sure whether it's discrete or continuous. Money.
Right. I guess that would be discrete because you can't have, I mean, nobody pays in half a cent.
People have argued both ways with money. Some people say it's discrete, just for the same thing that you just said. But is it possible? Is it theoretically possible that the price could be any number in between two numbers?
Theoretically, yes. Yes.
Yes. So in this, you know, if I was testing, I would never use money to ask you whether it's discrete or continuous, because I've heard arguments from on both sides. But I tend to favor the continuous, because remember, the limits of measurement do not determine whether it's discrete or not. And our limits of measurement are the act right, because we're moving into a digital world anyway. It's possible in the future we could move a price out to many decimal places if we wanted to. We're not going to be limited by coins and paper anymore eventually. So I would lean more towards the continuous, but if you said discrete and gave me a reason, then I'm okay with that because there's arguments on both sides. So that's a more not so clear, right? I think E is more clear. Sam's travel time from his dorm to the student union. Or maybe it's not. Well, first of all, is it quantitative or qualitative? Sam's travel time from his dorm to the student union. Somebody other than Steve. Han. Yeah.
Well, I think it's quantitative.
Yes. And is it continuous or discrete?
Continuous.
Continuous, right. It could be any number, right? Again, we're limited by the way we measure time. But we could, if we had it, if we brought time out to many decimal places, you could picture that happening, right? The example that we saw before, the number of people who attended your school's graduation, that's quantitative, but it's definitely discrete because even if you brought the decimal point out, many decimal places, it'd still be all zeros, wouldn't it? It wouldn't make any difference. It wouldn't make any difference how many decimal points you have. You still have the same number. That's the difference between discrete and continuous. You have to think about, if I ran the decimal point out, would it make a difference? Would it be different? And the answer is yes for both price and time. The answer is no for the number when you count. It doesn't make any difference if you add decimals to that. All right, so anyway, I kept a little bit past 9. I think I promised an hour, right? For this? Yep. I don't want to keep you too much later. Do you guys have any questions? Was this useful to go through exercises like this? Because I think
Yes.
if I spend the whole time lecturing, especially at 8 p.m., you know, you've already had dinner, you know, you had a hard day's work. If you listen to me the whole time, you're going to be like, when is this, you know, you keep looking at your watch, like, when is this going to be over? This is torture. I don't want to torture you. So that's why I want you to look at the chapter next, right? I think, what is our next, do you have a copy of the syllabus there?
Yeah.
What are we supposed to go over next Tuesday?
Section 2.2.
2.2. All right. So 2.2 is on frequency distributions and the histogram. So I want you to read through it. There is also, now there's a computer exercise at the end of this section where it says Minitab, right before the exercises at the end. I'm going to try to find that file, CX02SPEE. I hope they have it. I'm going to try to find it. This is an older textbook, so I don't know if the files they sent me is that one, but I'll look for it. If not, I'll send you another one and we'll do a different exercise in class. But I want you to at least read through everything else and see, and I'll go over the steps of how to do a frequency distribution and also how to do a histogram. I'm used to teaching this with the TI-8384 calculator. It's really kind of a nice way of doing it with that, but with Minitab, it should be a snap to do it. So go through that, and then when we go through this in class, I'll assume that you know you've been through this, all right, and you've read it, and we'll immediately start working on some problems with it, all right? I'll describe what these things are and then immediately go in and do some examples. Does that sound okay? Steve, is it okay?
Professor, could you repeat that last part? I couldn't really hear you.
Yeah. What I'm saying is go through section 2.2 on your own. Read it on your own. I'm going to see if I can find the Minitab file that they mentioned at the right near the end of the chapter or end of the section. If they do have it, I'll send it to you. If not, don't worry about it. We'll do an example like this in class. But I want you to read through it so you're familiar with it, so that when I actually go through it with class, I'm not going to do a lecture. I'm going to go through the steps of what these things are and how to do them with Minitab. Also, have your if you have a TI-80, I think Hannah's already gone. I don't think she has this, but you have your TI-83 calculator, 84 calculator with you. Have it with you, and I'll show you how to do it also on the calculator if we have time. But I want to emphasize Minitab and how to do it in Minitab. All right. And then towards the end of the period, we'll do a couple of examples together in class with Minitab. So make sure your Minitab's there. Make sure you have a calculator with you also. And that'll be it for now. So any questions? And I had also mentioned, sent you an email about Minitab's quick start, sending me something about it. I didn't want to make this into a compulsory thing. I just thought there was somebody in the class said, "Can I send it to you?" So I thought, all right, maybe I should just offer it to everybody. So if you do the exercises and want to send me the files to show me that you've done it, I'll give you some extra credit for doing it. All right?
Mhm.
A little bit of incentive there. All right? So I'll give you some credit for that. If you don't want to do it, that's fine. But I do want you to get through the quick start, at least, so that when you start using Minitab for real next time, it's very easy for you to know where everything is. All right, any questions? Can you hear me okay? Okay, good. All right, so I'll see you next Tuesday, and I will, I guess I will stop recording. And you can look at this again next time if you like, all right?
All right.
It'll be, it'll take me sometime tomorrow to do this. What I do is I put it out into YouTube. It takes a while for to generate a YouTube, and then I can actually attach this file directly from YouTube onto into Canvas. That's a very quick way of doing it. All right, so that's it.